Welcome to the class, dear students. In today's lecture, I am going to explain the application of the Laplace transformations. So, to solve this problem, the current I of t in an electric circuit is given by the differential equation d square I by dt square plus 3 times of di by dt is equal to 0. And with the initial condition I of 0 is 0 and I dash of 0 is 1. So, determine I as a function of t. So this is what the problem. Now what we do is we use the Laplace transformations for the given equation. So first of all, what is the given differential equation? We write it here. The given differential equation is y double dash. In the place of y, there is I, correct? D square I by dt square I double dash plus 3 times of I dash is equal to 0. Now, when you when you apply this equation 1, apply Laplace transformations. Apply Laplace transform to equation 1. Then what we get? L of I double dash plus 3 times of L of I dash is equal to L of 0, which is equal to 0. So now, what is the formula for L of I double dash? Already we have done in the previous lecture about this formula. That is S square times of L of I minus S times of I of 0 minus I dash of 0 is for, this is for L of I, right? So this L of I you are going to express as this whole expression, okay? And now let us go to write down 3 times of what is L of I dash. L of I dash is given by S times of L of I minus I of 0. That is by using the equation, the differential equation formula, right? So now that L of I dash is being represented as S times of L of I minus I of 0. Now, and this is equal to L of 0, which is equal to 0. Now what we do is we just group L of I, and that means here if I take L of I common, what are the terms in L of I? This is one term of L of I and this is one term of L of I, correct? So let us now write down L of I common as S square plus 3 times of S. S square plus 3 times of S. So that gives you S square plus 3 times of S. Now what is the initial conditions he has given you? This is I of 0 is 0 and I dash of 0 is 1. So what we write here? I of 0 is 0. So S into 0 is 0. I dash of 0 is given as 1. So this is equal plus 3 times of S already we have written, and I of 0 is also 0, and therefore this is equal to 0. So now what is your L of I? L of I times of S square plus 3S is given by 1, and therefore L of I is 1 over S square plus 3S. That means I can rewrite this as S into S plus 3. S square plus 3S, S is common, as S times of S plus 3 we can write. Clear? Now, and that gives you, we have to split this into the partial fractions. How can we split this as partial fractions? A by S plus B over S plus 3. So we can therefore 1 over S into S plus 3 can be U by partial fractions. By partial fractions we can write, we can split like this, and that gives you 1 is equal to A times of S plus 3 plus B times of S. Now when I put S is equal to 0, if S is equal to 0, what happens to this? That is A times of 3. That implies the value of A is 1 by 3. The value of A is 1 by 3. Now, if your value as S is equal to minus 3, if we substitute, then this becomes minus 3B. So that implies b is given by minus 1 by 3. So therefore, what is your value? 1 over s times of s plus 3 is given as 1 by 3 into s minus 1 by 3 times of s plus 3. Understood? The value of b is now minus 1 by 3. So we are splitting like this. So now let us call this equation as 2. So from 2 what we get is 2 implies what is I? I is L inverse of 1 over s into s plus 3. And now this is been written as L inverse of 1 over 3s minus 3 times of s plus 3. So can we rewrite this as 1 over 3 as common? I'll just take these values a bit smaller so that I can complete this in the same page. Bear me for just 2 minutes to get the solution here. It is easier. Right. Now I write this as 1 over 3 I will take common, and that gives you L inverse of 1 over s minus 1 over s plus 3. And we know the values of this. Therefore, what is I? L inverse of 1 over s means 1 by 3 times of L inverse of 1 over s is 1, and minus what is 1 over s plus 3 is e power 1 over 3 times of e power minus 3t. So this is what the answer. That is 1 by 3 minus 1 by 3 times of e power minus 3t is the solution. I hope you could understand. So this is what the application of the Laplace transformations, the application of differential equations, Laplace transformation in the differential equations. I hope you could understand. Thank you.